Hi, this is Dr. John Bergdorf. In this video, we're going to look at a very important mathematical concept known as closure. A set is closed with respect to a given operation if and only if, whenever that operation is performed on any two elements of the set, the result is always another element of the set. Let's look at that closely. First of all, the definition requires two things. You need to have a set and you need to have an operation. A set may be closed with respect to one operation, but not closed with respect to another. Let's look at this relative to an example. Example, the set of whole numbers is closed with respect to addition. So notice that there is a set, the set of whole numbers, and an operation, addition. So reminding ourselves, the whole numbers, which we sometimes represent with a W like this, are the numbers that we count with plus 0. 0, 1, 2, 3, 4, and so on, like that. Is this set closed with respect to addition? What that means is that if you pick any two elements of this set, will you always get another element of that set? Let's do some examples. Let's suppose you pick 3 and 4 and you add those. You get 7, which is another element of the set. That's still a whole number. Pick any two whole numbers, no matter what they might be. Will you always get another whole number, another element of the same set? And I believe the answer is yes. No matter how far you may go, you add any two whole numbers and you will always get another whole number. So the set of whole numbers is indeed closed with respect to addition. We're going to look at more examples, but just to give you an analogy to help understand or feel comfortable with the word, when I think of the word closure, I think of a walled castle. And the walled castle keeps everything that's in the castle safely inside the castle, and everything that's outside of the castle stays outside. So if a set is closed, if you take two numbers that are inside the castle and perform whatever the operation is, they stay inside the castle. There's no way that you get a result that's outside the castle. It doesn't sneak out somehow. And on the other hand, if you take something that's outside the castle, it won't get in. So the castle is closed. So when you think of closure, maybe think of the idea of a castle. Let's do some more examples right here. So in all these cases, we're going to ask ourselves, is the given set closed with respect to the given operation? Anytime you pick any two elements from whatever the set is and you perform the operation on it, do you get another element of that set? So let's think about, for example, the whole numbers. Are the whole numbers closed with respect to subtraction? We just looked at them with respect to addition. And at first glance, you might think, well, sure, I believe that will be the case. If I take the whole number 9 and subtract the whole number 7, I will get another whole number. I'll get 2. But the important thing is that has to happen whenever you pick any two numbers out of that set. Look at what happens if you just change the order. Here I'm still picking two elements of the set of whole numbers, but when I subtract them, I get a negative number, and the whole numbers do not include the negatives. So are the whole numbers closed with respect to subtraction? The answer is no. If you change the set, maybe it will be. Are the integers closed with respect to subtraction? See, the integers, which we often represent by the letter Z, includes the whole numbers and all of their opposites. So that would be this set, -3, -2, -1, 0, 1, 2, 3, and so on in both directions. And here, if I took 7 minus 9 and got -2, I'd be just fine because that would be an integer. I can even throw in all kinds of negatives if I want. -3 minus -2, that's picking two integers and subtracting them. Remembering that subtracting a negative is the same as adding a positive. That gives you -1, which is still in the set. In other words, I believe that no matter which two integers we pick, when we perform the operation of subtraction, we'll get another integer. So the answer to this question is yes. Are the integers closed with respect to multiplication? Again, the idea is pick any two elements of the set, perform the operation on it. Will the result also be in the set always? So if we multiply, say, a positive integer by another positive integer, you get a positive integer. If you multiply a negative integer by a positive integer, you get a negative integer, but it's still an integer. I believe this is always going to be the case, that no matter what you pick, the product of any two integers will still be an integer, and that answer is yes. So the integers are closed with respect to multiplication. A couple more examples. Are the integers closed with respect to division? So you might remember we just figured out that the integers are closed with respect to multiplication. What about division? And the deal is, this means that no matter which two integers you pick, anytime you pick two elements of the set and perform the operation on it, you're supposed to get an element of the set. You might pick in a lucky fashion. It is indeed the case, for example, that -9 divided by 3 is a integer. It's -3. But what happens if you take 2 divided by 5? 2 divided by 5 is 2/5, or 0.4, and that is not an integer. So the integers are not closed with respect to division. Let's get some fancier ones. How about the even whole numbers? So that's your set. Look at the set of even whole numbers and apply the operation of addition. So imagine adding any two even whole numbers. They've got to be whole numbers and they've got to be even. 2 plus 4. You get 6. That's another even whole number. 8 plus 14. 22. I believe, and of course you have to convince yourself that this will always be the case, but I believe that no matter what you pick, if you pick any two pick any two even whole numbers, you're always going to get another even whole number, no matter how big those numbers are. This answer is yes. However, if we look at the odd whole numbers, are they closed with respect to addition? The idea again is pick any two numbers in that set, elements of that set. What if we pick like 1 and 3? Those are odd whole numbers, but look at what happens. When you add them, you get an even number. That falls outside the castle. And so this set is not closed. Just a few more. Oh, here's one written in set builder notation. So let's understand what this would look like. The set of all values of x such that x is equal to 3 times n, where n is a natural number. So the idea here is you pick any natural number, and let's see if we can generate the set. If n, let's make a little chart out of this, just to get us started, and then we'll see the pattern. Pick any natural number, and we're picking natural numbers this time. We're not picking whole numbers, but natural numbers. So that's just 1, 2, 3, 4, 5. If n is 1, then from the formula, x would be 3. If n is 2, x is 6. If n is 3, x is 9. So pretty quickly you realize that what this set is the set of multiples of 3. 3, 6, 9, and we could go on to 12, 15, and so on. Is this closed with respect to addition? And the answer to this is going to be yes. If I take one number that's a multiple of 3 and add it to another number that's a multiple of 3, the result is going to be a multiple of 3. This set is closed with respect to addition. All the sets we've looked at so far are infinite, but you can play this game with finite sets too. What if we take just this simple little set, 0, 1? Is it closed with respect to multiplication? Pick any two elements of that set and multiply them. Do you get another element of the set? Now, watch this closely, because at first glance you might think, well, there's only two elements, so the only operation I could look at is 0 times 1, which is 0. And we say, okay, that's in the set, so we're good. But when you pick two elements of the set, it can be the same element. So we really have to concern ourselves with, is 0 times 0 also in the set? Yeah, it's 0. Is 1 times 1 also in the set? Yes, it's 1. And that's every possibility we have. Well, I guess we could look at 1 times 0, but the commutative law says that 0 times 1 and 1 times 0 is the same, and it surely is. This set is closed with respect to multiplication. What about, is it closed with respect to addition? Well, if you pick in a lucky fashion, you might begin to think, yep, it's going to be closed with respect to addition too. 0 plus 0 is 0, and 0 plus 1 is 1, so the sums we're getting are in the set. 1 plus 0 is also 1, so you're getting very excited that, yes, this is probably closed with respect to addition, but let's do one more. Because I can pick the 1 twice, 1 plus 1 is 2. That's not in the set. It gets outside the castle. These elements are not all safely staying within the castle. This set is not closed. So I hope this little video illustrates nicely to you what the concept of closure means in mathematics.